SQLite powers nearly every app on your phone. It's a database in your messaging app, in your calendar, but also in the browser and countless other applications which are running on your devices. It's bundled into Python, and it's also only one install, for example, in Ruby or Node. And its magic is in its simplicity. It's one file to back up, to move, or to version. There is no complex deployment. There are also no state management headaches. But up until recently, search in SQLite was restricted to keywords. But now we can build semantic search and hybrid search right in the local database. And today we are talking to Alex Garcia, who is the creator of SQLite Vec. And we talk about how SQLite Vec works, the optimal use cases, and how you can optimize it for your use case. And instead of basically having a massive central search database, each device can maintain its own search index, and the computation happens on the user hardware. So results are near instantaneous with no network delay, and also private data never leaves the device, which is probably the main motivator why you want to do this. And this really shines for end consumer or really privacy aware or sensitive applications like in medical or healthcare. Let's do it.
It's row-oriented storage. It doesn't have good compression or good some of the other benefits that you get from column-oriented stuff you don't get with SQLite. And also, since SQLite is divvied up into pages of data, and that's how things are like written and stored. Most of the time, that doesn't matter for most applications, but for SQLiteVec, it does because. And I guess we'll talk about this later, but SQLiteVec stores all vectors in like big chunks, like giant blobs that are like a couple megabytes in size. And the problem with that is since page sizes in SQLite are like 4 kilobytes each, that means on disk, it's stored in like several different pages all throughout. It's not like a contiguous block of memory. So there are small quirks like that make some like analytical stuff a little bit hard to do in SQLite. But like the benefit is that if you're doing like transactional stuff, or you have an application that has many writes, it distributes it quite easily, and it could do writes a lot faster. So that's usually the main benefit between DuckDB and LanceDB for that kind of stuff. That when you're writing an application, it's usually faster, especially writes. But it is a little bit weird. The documentation for SQLite and how they like the file format storage is quite like verbose. Like every single byte in the header page and all the other pages that exist in it, there's a lot of documentation for it. And there's a few tools in the command line interface where you could like view every page, see what data is in there, B trees, leaf nodes, all that stuff. So it's a little bit weird, but I guess since it was built for like transactional stuff, it makes a little bit more sense.
Yeah, so why did you decide to do SQLiteVec, especially on SQLite, and not choose one of the other data formats? You could have done it probably in DuckDB as well with WASM, or could have done it in LanceDB as well, on Lance or even Parquet.
Yeah, I think I use SQLiteVec a lot for other projects like data analysis stuff and pipeline work and even small little applications. So I was already using SQLite a lot for that kind of stuff. So building something for that made a lot of sense. And I think with SQLiteVec compared to a lot of other database technologies out there, it's fairly small. It's very lightweight. The extensions, it's very easy to build extensions, whether that's scalar SQL functions or table functions or virtual tables and all that stuff. The documentation is quite nice and it's been around for a while and it's quite stable. And I didn't go along thinking, when I started SQLiteVec, it wasn't like, I want to build vector search, let me find a database for it. It was much more like, I'm a SQLite guy. I use SQLite for a lot of projects. I want an easier vector search thing that I don't have to install 10,000 dependencies to use. I just want something lightweight and something that works in my current workflow. So that's how I stumbled into SQLiteVec specifically. I use SQLite most of the time just because of how easy it is to use. It's already bundled into Python. For most other programming languages like Node or Ruby, it's just like one install away. So it's fairly easy to set up, as opposed to some other databases that are a little bit larger, requires way more setup commands or separate server or whatever. So that's most of the reason why I was already in like the SQLite world beforehand.
Yeah, and especially SQLite, why I love it as well in the past few months is just you can't just have a local copy of the database and you can experiment, which isn't there for most of the other databases.
Yeah, and you could just, it's a single file, right? So you can like copy and paste it if you want to make a backup. That's not like transactionally safe, but you can do it. It's like completely fine. So it's really easy to run a quick experiment, destroy it if you have to, back it up by just like uploading the DB file to like Google Drive or S3 or whatever. So yeah, that's definitely another main reason why like I usually reach for SQLite, just because it's so easy to set up, don't have to do much, just single file, very simple.
Yeah. What are like some of the use cases or like some of the fun stuff you tried out with SQLite Vector, especially with like local search, local AI on top of SQLite?
Yeah, I think most of my initial projects with SQLite Vec have just been like a better search engine, right? So SQLite already has full text search and already built a lot of applications in the past, whether it's like personal stuff or for clients, that is just like a straight up search engine, like keyword search, all that stuff. But of course, it's just keyword search, right? There's no like semantic search, there's no fuzzing or like deriving the semantic meaning out of it or whatever. So when I built SQLiteVec, that was the main thing that I would do, was if I had a pre-existing search engine, add vector search to it, and then you get like all these cool new results from it. That's been my main focus, just because of how easy it is and how it integrates very well with the pre-existing SQLite full text search extension that exists. So that's been like my main focus. I think there's other fun little projects that I've done where it's building a small little classifier, like a text classifier on top of vector search and embeddings. Again, very easy to use in SQLite, just because if your data is already in SQLite, it's very easy. And if it's not, it's very easy to get your data into a SQLite database. And once it's there, embedding those and building like a little classifier on it to get like the k nearest neighbors, and then find a label of the most common label of the closest 100 vectors or whatever. That's been my focus so far. I think also because I have a background in data analysis and data engineering kind of tasks. So that's usually what I go for when I build. Whenever I'm using SQLite, it's usually for some data analysis project. So building a search engine or building a small little classifier makes a lot of sense. I don't do a lot of, and I occasionally do, but that's my main focus isn't in like building AI applications, right? I've seen other people and I've heard other people talk about building a command line interface that uses SQLiteVec to store embeddings, right? Because it's how easy it is, how it's like on your computer right there. Or maybe it's like a little web server that like does some sort of embedding plus storing in SQLiteVec and stuff like that. So on the transactional application side, I've done small little projects here and there, but like my main focus has always been like build a search engine, build a classifier, do some like recommendation related stuff with SQLiteVec. That's been mainly my focus there.
Yeah. And where are those actually embedded? Are they running like in web applications in the front end? Are they running in the back end, embedded in one of the Cloud Runs, Cloud Functions?
Yeah,
VMs?
so I think initially people would just run it, SQLiteVec when it first came out, since it was a developer tool, it would be running on your laptops, right? So local development server on your Mac or Windows machine or whatever, running in a command line interface, a little web app that you have. I've heard people running it on cloud applications as well. So like they deploy it at AWS, or Google Cloud, or Cloud Runner, or any of those different places. And they're either storing or doing like vector comparisons with SQLiteVec on those platforms. It is totally possible to use SQLiteVec in like desktop applications as well, mobile applications. I recently added support, and I will be adding better support for Android and iOS. So you could theoretically run SQLiteVec and store vectors in a SQLite database on your Android phone or on an iOS application and such. It runs on a Raspberry Pi. Actually, I have a little device here. This is a Raspberry Pi Zero. It doesn't need Wi-Fi, but it has a little like keyboard and e-ink display. It's called a Beepy or Beepberry. And this can run SQLiteVec. It's just a Raspberry Pi, so you could like SSH into it, compile or download a copy of SQLiteVec, run it on here. And you could have those embeddings run, and you could generate embeddings on here, generate embeddings on the server, or wherever else you run. So it's my main focus was like get SQLiteVec running everywhere, right? And it does run everywhere, including WebAssembly in the browser, mobile devices, all that such. And I've heard anecdotally people running it on these platforms as well, and either like test applications or trying things out. Mostly because also SQLiteVec is fairly new; it just came out like a few months ago.
Yeah, I think it's very interesting, especially with the entire local first movement happening, which got so many endorsements from like all over the place, which I would have never expected. And I think the local AI part is something I'm seeing more and more, and we are implementing more and more. And I think SQLite is a very interesting choice for that. I will be on the lookout whether Apple is integrating SQLite Vector 4 in their like messages or contacts.
Yeah, I know that Apple, with their Apple Intelligence stuff, they do like on their slides, they say semantic index, which is an on-device vector index of some sorts. I don't know if they probably don't use SQLiteVec. I know that with Microsoft, they had the recall AI feature that was like, it would take screenshots of your computer every so often, and you could talk to your computer, be like, oh, what was I doing on this website before? Which first off had like a ton of privacy and security implications that was just absolutely terrible. But one cool thing that came out of that was that Microsoft was actually storing their vectors inside of a SQLite database on your computer. So it wasn't like syncing to the cloud or anything. They used their own custom implementation. They didn't use SQLite Vec just because it didn't exist back then. But they did have some form of like disk ANN support that was built on SQLite where the nodes and edges were stored in a table. It was a complicated thing. But I think that showed that like the technology stands, right? If these companies are building a local AI stuff and they have all these resources and they just end up storing their vectors in SQLite, then this is a pretty good approach, and it'll probably work in other places as well. Yeah.
Yeah. What I'm really interested in is especially the like how far you can push it. Like, what are the limits, especially like of search speed, but also of index size, especially when you get into the larger embeddings, like 1,000, 2,000, even 4,000 dimensions?
Yeah, I think first off, for limits of SQLite in general, they say that you can store terabytes, like 100 or 200 terabytes of data within SQLite before it actually hits its theoretical limit. But I think the actual practical limits are much, much smaller. I think for SQLiteVec specifically, right now SQLiteVec is just brute force search, right? It's just linear search. It compares every single vector inside. There's no approximate nearest neighbors index yet. It just does like a brute force across everything. I mainly did that for one, it was much easier. Two, SQLite is the storage format for SQLite is very specific, and some of the ANN indexes that are out there just may not work with how SQLiteVec stores data within B trees and pages and all that. So I didn't really want to choose one where I didn't really want to choose an ANN index too early and figure out it was wrong and then have to change things later. So I just held off on that at first. But I think practically, the practical limits for SQLiteVec, it's probably going to be like, from what I've seen, you could do tens of thousands or hundreds of thousands of vectors where the dimensions are like 768 or 1024. Like you could probably like store tens of thousands or hundreds of thousands of vectors before it takes too long to search. I think what I tried was a 768 dimensional vectors. I could probably store like 500,000 of those inside of a SQLite database, and the search results would be like around 500 milliseconds or so. So I think in general, I like when searches, especially most SQL queries, to take less than 100 milliseconds to execute, because then there's a lot of other overhead, and that's typically around like where people can like really tolerate, or before they even notice that results are like quote unquote slow. So I would say tens of thousands to hundreds of thousands. And if you have like larger dimensions, like 2,000, 3,000 dimensions, and like probably even smaller, then probably like the 100,000 range would probably be a little bit too much, at least for this initial full scan linear search brute force thing that SQLiteVec does currently. If you could tolerate it, SQLiteVec does have quantization support. So if you want to do binary quantization or scalar quantization or matryoshka embedding, so you cut them in half or cut them at a smaller distance, SQLiteVec does have support for that. And with that, you could probably like add a little bit more, right? With binary quantization, it's 32 times smaller. So you could probably do like 1 million binary vectors in SQLiteVec before you notice some performance issues there. So that's typically around like where it is currently. I want to get it in a better place. I think with a proper ANN index that will be a part of SQLiteVec in the near future, I can imagine it doing 1 million, maybe like a few million vectors before you really hit some limits that where SQLite and SQLiteVec wouldn't make sense. I think another thing it would be metadata filtering and partitions, which will also be included in SQLiteVec very soon. I think that could help it scale even more, right? Because even if you have 10 million vectors, if you're only searching a subset of those, you have 10 million, you have 1,000 users, all those users have 1,000 embeddings, that's 1 million vectors. It might be too much to brute force search, but if you only search for one user at a time, you only search for their 1,000 embeddings, searches can be a lot faster and it could be a lot more tolerable. And I'll be including features that support that, including partitioning data and all that stuff, and metadata filters relatively soon in SQLiteVec as well. So yeah, I think currently, all that to say, currently tens of thousands, maybe hundreds of thousands vectors. If you do binary quantization, maybe 1 million. But with some features that are coming down the line for SQLiteVec, I imagine it could support low millions, maybe 10 million vectors.
Shouldn't you already be able to do like metadata filtering by just filtering down on another column? Yeah. And then doing the vectors?
You could. So there's two ways of storing vectors within SQLiteVec. One way is a manual way where you just store a JSON array of text or a blob of vector data inside of a regular column in a table. And that works just fine. There's SQL scalar functions where you can manually compute distances and then just do select all from order by distance, limit 10, and that's a KNN search, and that works just fine. There are some performance implications with that. If you have very large vectors, say if you have a 2000 dimensional vector, that's going to be like 8 kilobytes of storage per vector to store, right? And if you're storing that alongside your other data in a regular SQLite table where that data is stored in a row oriented format, there could be performance implications there where like the disk head has to like scan through a lot more data to do that because you're storing these like large blobs within a table. So there are some like performance implications out there if you're doing that. So another way of storing vectors within SQLite is using a virtual table. So we have it's a virtual table called Vec0, and it's very similar to the virtual tables that are found in the SQLite Vec full text search extension and R-tree extension. It's create virtual table, and then there's some configuration options you could add there. What that virtual table does is that it stores vectors within a SQLite database, within your SQLite database inside of shadow tables, but it chunks vectors into large blobs where it's like a large chunk of 1,000 vectors. And that makes searches a lot faster. It stores data completely separate from your other data. So it's like a separate table you have to do, and you kind of have to do a join, which could be a little bit awkward at times, but it works just fine. And with that, searches are much faster. And there's some other like performance gains we do that because we store things in a contiguous block. We could read it into memory a lot faster. We could do things like S acceleration, stuff like that, SIMD acceleration. So there's a lot of benefits to doing that. But the problem with that virtual table is that there's currently no metadata filtering there. That's something that I would have to implement myself. And that's something that I will implement, and I'll have typed where you can like just what metadata filtering will be in SQLiteVec when this is completed on Vec0 virtual tables. It will just be regular columns, right? So you can declare extra columns alongside your vector index. You can do metadata filtering with where clauses. So it's just like where submitted at is between these dates or where this label equals red or whatever. So that will come and that will be a part of in general, but it's just not a part of the virtual table implementation yet. But if you're doing things manually, you could totally do that yourself. You can do, if you're storing it alongside of a regular column, you could do normal SQL queries on top of that and be just fine. I think another thing is you could also do pre-filtering with both the manual implementation and the virtual table implementation, where if you have you could do another SQL query that just returns a list of probable IDs or IDs of items that you want to search. So let's say, for example, get all the documents that this user has access to. And then you can pass in that allow list into the query for virtual tables and Vec0 tables, and then it would just consider those when doing comparisons. So that is one way of doing it, but it could be a little bit slow. It could be not as performant as some of the other ways that will be coming down the pipeline in a little bit.
Yeah, that's very interesting. I think my mind already jumped instantly to re-rankers as well. That you actually could support re-ranking with when you have especially like local search applications or some form of recommendation system in the front end, which could make it way faster, especially if you imagine like an e-commerce site, but the user is already navigating the page. So you have some filters available when the user is navigating and you have the search query. And I think this could be like an interesting addition to SQLiteVec as well. Like adding some re-ranking capabilities could be very cool.
Real quick, do you mean like a re-ranking model or just re-ranking a binary a bit vector and then re-ranking it with like a full size vector?
No, a re-ranking.
Oh, re-ranking model? Okay, yeah.
But in the end, a re-ranker often integrates like multiple different factors. Yeah. So it's often combined also with, for example, a score for the recency of the data.
Oh, interesting.
Or a score of like past interactions, for example, of popularity is a common score that you actually add to the different items. And you basically can implement like or add business logic to the re-ranking as well, that you don't just have basically the query and document or query item re-ranking score, but you add like more the business logic scores also on top of that. So you can optimize for certain parts.
Yeah, I wasn't aware of that. I always thought that re-ranking models just re-rank based off content itself. And I always thought that that value was limited. But if you could like include other metadata like popularity and stuff, that's pretty cool. It sounds like it could be a main part of SQLiteVec. That'd be interesting.
And there are like two ways of implementation in the end. One is you actually implement or train it into the re-ranker by actually using like the popular items in your training data set. But in the end, this like biases it towards like very popular items all the time, which is something you often don't want to. And you can also basically just use it as a weighted score in a weighting function, which is often a little bit more controllable.
That's so cool. Yeah.
Nice. And I think for me, it's with embeddings when I'm working with them, I'm often fine-tuning models and keeping it up to date because you have some data-driven practice. How could I approach that with SQLite Vec? And especially when I'm assuming I have it deployed on multiple different devices or multiple different customers, how can I actually keep the embeddings basically up to date with the most recent model?
That is a good question. So it's a different embeddings model that you fine tune and train, and like you insert some vectors and you embed some stuff on March 1st, and then on March 14th you train a new model on those embeddings, and you want to go back and update the previous embeddings you had with the new model. Okay.
Yeah.
SQLiteVec in general is just SQLite at the end of it and just pure SQL. So you could go back and update a table or a virtual table that has vectors in it with new values that you have. You could also have triggers as well. So like when so for example, if you're embedding comments from a YouTube video and you have a column called comments, and that's the actual like text comment that someone left on a video, and you're doing some vector search on top of that, so you're storing those embeddings of those comments in a separate virtual table with SQLiteVec, or just in another column that's a JSON array or a blob representation of a vector. You could always use triggers. So whenever you have to update the comment, or whenever a comment is updated, you could have a trigger that goes and updates that virtual table or updates that other column with a new representation of what the embeddings of a new embeddings representation of the new comment. And I think if you are syncing with a new fine-tunings model, or if you change the entire embeddings model in general, I think an update like that would probably be what's needed. And as long as the dimensions match up and all that, it should work as expected. Don't know if I have a good answer to that one.
Yeah, I think that's one of the, especially in the local first era, that's the most challenging part, like the syncing between like different devices, between the user and the backend, and how to actually make that possible without like overrides if you have multiple users working on the same data. Which is a very challenging problem.
There are a few tools and features that people have built that like wrap SQLite to do some synchronization work, where you have multiple people with their own like version of a SQLite database, and then it eventually all gets synced back to the main master copy. I don't know what the status of those tools are. Some of them could be like quite complicated to build, and they may not have a lot of funding. So I don't know exactly if there are any good options out there. And I guess I don't know how well they would work with SQLiteVec in general, because SQLiteVec uses virtual tables. You might be able to sync the underlying shadow tables where the data is actually stored, but I've just never tried that myself. I think there are a few like good backup options for SQLite where it'll continuously replicate what you're working on into S3 or some other replication tools that are out there specifically for SQLite. SQLite does have some form of, there's a session extension where you can like, it's not necessarily like forking a SQLite database, but if you have your own copy of a SQLite database and you make edits to it, and then you want to sync those edits with someone else and have them merge together and then raise an error if there's a conflict or whatever, there is a session extension that does part of that. It's not very well used. I don't know how often it's used in like real world environments, but there are some ways of doing that and some ways of synchronizing. But I think since SQLiteVec, if you're using the virtual table implementation, it might be a little bit hard to work that into some of those tools.
Yeah, I would really love to try to build like a local only recommendation system, which basically collects the user data only in the front end, adds it to a vector database, gets the items, embeds them, and then basically does the recommendation. This would be a fun side project to actually
I think
try.
I usually get around like synchronization issues by just not synchronizing and just having it like completely local, where you don't need to like share with other people or do anything like that. Just like try to make it more private if possible. That also just sidestep the entire issue. Maybe not the best approach, but
what I would love to hear, what are like your go-to models on when you're building the local stuff? Are you using custom models as well, or are you rather tending to go with something like Cohere or OpenAI's embedding?
I try to do open source models as much as I can, and I avoid OpenAI and Cohere, mostly because being able to write it myself, I find can be a lot easier and a little bit more future-proof, and you don't have to pay for it, which is great for cost and all. When I do choose an open source, I typically choose a sentence transformers model, mostly because those can translate into a GGUF format for llama.cpp, which is usually the inference model or the inference engine that I use when I do embeddings models, whether that's with LlamaFile, which is a Mozilla AI project where you can run local models, including embeddings models, and generate embeddings through that. That takes GGUF model files, and I like those just because like it's much easier to run. It's just a single file, SQLite. The inference engine itself, llama.cpp, it's just like pure C++. It's very easy to compile and use in other projects. I also have another SQLite extension that's like a sister project to SQLite Vec called SQLite Embed, which uses llama.cpp to generate text embeddings. That's usually what I use as a go-to because I'm already in the SQLite land. A GGUF model is fine, and sentence transformers does you can convert a sentence transformers model into a GGUF format quite easily. I typically choose the really small one. I forget the name of it just because it's a bunch of like numbers and letters. It's like the all mini L2 version 6 something or the other. That one's it's 30 megabytes. It quantizes very easily. The only problem with that one is that the context size is fairly small. It's only a couple hundred tokens, I believe. But I like it because it's very small, quick, and easy. And it was trained a while ago, so it doesn't know a lot of like recent stuff. So if I do want something that's a little bit more recent that knows things about COVID-19 or anything like that, then I have found Salesforce has a few embeddings models recently. I think it's called like Arctic Embed. No, I'm sorry, that's Snowflake has a few embeddings models called Arctic Embed. The recent version 1.5 is fairly nice. It does have some support of Matryoshka embeddings and a few other like nice features that come with it. A little bit larger, a little bit more difficult to run just because it's instead of a 30 megabyte file like the other one is. This one's like probably in the couple hundred megabytes size. But that one is it's trained on more recent data. It works with more if you're working with, for example, I was working on a little project that does news article headlines, scraped the last couple thousand headlines from NBC News for American newspaper, and then doing searches on top of those headlines. And those are fairly recent topics. Some older embeddings models may not know about it, but this Arctic one seems to know a lot about it, so it does like pretty well. I also try out Nomic has a few open source ones. Mixed Bread has a really good embeddings model that does binary quantization very well. So whenever I can, I just try an open source model just because like they're easy to run. They're free. You don't have to worry too much about hitting another API or whatever. I think another nice thing about using a local model is that you don't have to, it might run faster, not because it's running on your own hardware, but because there's no network delay or you don't have to worry about API keys or sending in a REST API request or whatever. So keeping it local kind of makes that part a little bit easier and less likely for there to be bugs or crashes or whatever else.
Yeah. How have you experienced like the system demands when you're building something, especially user facing, and when you have multiple different models running? You have one file for like your transformer model for generating text and LLM, and one embedding model, maybe even some stuff on top of it. Have you seen any interesting strategies swapping in and swapping out different models into memory, or something interesting how that is handled?
Not that I've seen. Typically, the most I have running is, like you said, like maybe one LLM if it's doing like a RAG application. So one LLM style model where maybe it's Llama or something else that does like text generations, and another model that's strictly for embeddings, whether that's Snowflake, Arctic Embed, or whatever. Typically, the embedding models are fairly easy to run. They're like probably less than a gigabyte and more so even smaller than that. So it doesn't take up a lot of memory or RAM, so you don't have to worry too much about it. If I was running multiple models at the same time, yeah, I don't know if there's a lot of good strategies for like swapping out memory and all that. I would just shut down the instance or have a separate server. I think one nice thing about doing local stuff is there's a lot of other tools out there that kind of make it easier to talk with like other devices on your network. So I develop on a 2019 MacBook. It's the old Intel processor. It's fairly old now. It doesn't have a lot of RAM. I can't run like Llama on it or anything. But I do have a newer Mac Mini that sits on my desk all the time. And I could always SSH into that and run another model, right? Or I can use Tailscale to access my Mac Mini if I'm out at a coffee shop or whatever, right? And that could run Llama, and I could run the embeddings model on my computer, and the network delay may not be too bad, right? And that's one way to just like if you're running stuff on device, you probably have multiple devices on your computer. Maybe you could use some of them to do like a hybrid mixture of things, right? Or of course, you could always pay someone like OpenAI or Anthropic to host a larger LLM model for you if you wanted to do that. So there are like ways of either using multiple devices or just using another server if you have like multiple models running. But I don't know about if there's a good option for swapping models like in memory and stuff. Yeah.
Yeah. On the topic from before, the current models, I think I still have a strong preference of using models before 2021, especially embeddings models, because I'm still uncertain about the impact of all the AI generated content on the web, which is now basically in all the different models. So I really like all the BGE models, which are fairly good if you actually fine tune them as well. through which you actually get the relevant information or knowledge into the model as well.
Yeah, I think fine-tuning is probably required for a lot of applications. I think when you're developing or doing prototypes, you don't really need that stuff all the time. But yeah, like as soon as you have an actual use case for it and you have an evaluations data set and you just need to get like something out and done and like actually in front of customers or users, then like fine-tuning is probably going to be required for whatever you do. Yeah. And
yeah. Anything beyond that in your stack, especially like you mentioned the Llama file, probably Transformer.js for all the sentence transformer stuff when you're in the front end. What else is in your tech stack or in your go-to tech stack?
Yeah, there's always like developer friendly tools that I use. Simon Wilson has a LLM command line interface where you can interface with multiple different either hosted LLMs, whether it's OpenAI or Anthropic or whatever, but also local models as well, and also local approaches, whether that's like MLX or llama.cpp or PyTorch or whatever. I think that command line interface is a good way to try out different models, just to run things on the command line. I think for building applications themselves, yeah, I typically default to like llama.cpp, mostly because it's easy to run on device and easy to compile and use, compared to like things like PyTorch or TensorFlow, which can be like, at least in my past, very difficult to compile or run on many platforms. So having something that's one binary, one model or one file for the model itself with llama.cpp, that's usually my go-to. Transformers.js, definitely a big one for working inside the browser. There's a lot of different there's a lot of different embeddings models that run in the browser through TensorFlow.js that I use whenever I want to have a demo of SQLite Vec running in the browser, or just having a semantic search in the browser. That's usually my go-to. I think some other projects, llama.file is a big one. LlamaFile also has Whisper file as a new feature where you could run Whisper on a single binary that runs on multiple operating systems, which makes my life a lot easier when working with audio. Yeah, that's all I can think of right now.
Yeah, I saw the Whisper file. The Whisper file is really interesting. Have you played around yet, especially with VLMs as well, like vision language models on operating on images and other types
Unfortunately
of
not. I think the reason why is because Llama CPP doesn't have good support for vision models. They had initial support for one or two of them in the very beginning, but they slowly just got deprecated or bit right away where they don't really quite work anymore, which is quite disappointing because I think in the last like month or so, there's been a lot of really cool vision models that have come out. To use them, you have to use PyTorch or a pre-configured Colab notebook to actually use it. And I've just avoided that just because I've wanted to run things locally. But some of them look really cool. I think vision models are probably going to be like the next big thing for the next few months, whether that's specifically trained for OCR or handwritten text or like image recognition and all that. There are a few clip embeddings models that I've played with, and SQLiteVec, of course, it works with them because at the end of the day, they're just embeddings. They're just vectors you could store inside of any vector database. But yeah, I think there's going to be a lot more movement in that area and a lot more models, which I appreciate and I love. I just hope they get easier to run and they're easier to run on other platforms. Because I think even like TensorFlow may not have great support, or Transformers.js may not have good support for them yet, just because the inference on vision models are much different than embeddings and text models, and it may take some time for them to really support that. But yeah, I just hope they get easier to run soon.
I would also expect that vision language models in general, they have to get like bigger and bigger first before they can get smaller and better again.
Yeah, same thing with like text models, right? They got bigger and bigger, and now I think they've figured out like some good strategies to slim it down or better training data. So now, things like the GPT-4 mini are much smaller and faster to run, or some of the new Llama models that are smaller parameters are better than the ones that were like larger parameter ones from even 2 years ago. So I think that little hump is coming soon. The little hump that happened with text models a few years ago is probably going to happen soon with vision models as well.
Yeah. Have you actually benchmarked SQLite and SQLiteVec against the other like more common for tools for local first vector databases or local first search, like for example Chroma, Sync, but also if you're running on the server, Fice is like or tends to be my go-to.
I have run benchmarks. I don't know if I completely trust them because benchmarks can be a very sensitive topic for a lot of people and a lot of other projects, but I'm confident in saying that SQLiteVec with a few parameters tuned is much faster at brute force vector search than a lot of other client libraries, with the exception of Fice. Fice is just so much faster than a lot of other ones. If you're doing brute force, Fice is much faster than SQLiteVec. There might be like one or two other vector search, like C++ vector search libraries that are faster than SQLiteVec. at least in like brute force, all in memory, all that stuff. I think some other libraries out there, they don't really like, they're not optimized for linear scans or for brute force scans because they care about ANN index speed and recall and all that. So in that case, SQLite Vec isn't faster than any of those because SQLite Vec is brute force, and any ANN index is going to be much faster than a brute force search. But I would say that like in general, since SQLite Vec is much smaller, easier to run, and easier to install, and also inserting data into SQLite Vec is fairly straightforward because again, it just stores it one after the other. It doesn't have to navigate through an HNSW graph or a disk and graph to like insert stuff. Usually inserts are much faster, and usually searching and KNN queries are faster than in SQLite Vec than some of those other tools. Again, for brute force searches.
And also, I think what's an underappreciated aspect is like that you have an actual data model, which often makes the iterations way faster because you have to think about your data first of how it looks. And you also can easily run all the different filters, pre-filter, post-filter, with the additional columns you have in SQLite.
Yeah, and also one nice thing about SQLite and SQLite Vec is that it just does less things. So there's less things to slow it down. So for example, the actual like storing of data and writing to disk and all that, SQLite Vec just uses SQLite to do that, right? And SQLite has been optimized for very fast disk writes and reads for the past like 20 years. Whereas some of these other like vector databases or local first vector tools that are out there, they had to implement everything from scratch, right? They like they do their disk access, they wrote themselves, or they have transactional stuff they have to write themselves. They have to write their own database, right? Whereas SQLiteVec just use a pre-existing database that's out there that's optimized for all the speed and inference, or optimized for speed and quick writes and all that stuff. So that is one nice thing about SQLiteVec, is that because it's on SQLite, a lot of things just run much faster because of it, because it's a proven technology. And we don't have to spend a lot of time like deserializing or thinking about like how we're going to store things on disk, mostly because SQLite already figured out most of that for us, if that makes sense.
Yeah. And what would you actually say? What's missing from the space?
I think on the vector search and vector storage side, not much. I think in the next few years, there might be some like better ways to like store vectors, or a better ANN index that someone comes up with that's faster or has better recall or whatever. So I think on that side, I don't see much happening. Again, there might be some new quantization techniques or new ways to store and query vectors. But I think the real innovation in this space is probably going to come on the embeddings models side. So with these embeddings models, if they become smaller, faster, easier to fine tune, easier to use, I think that's going to have a way bigger impact on vector search, semantic search engines, recommendation systems than anything that like the vector database can do itself. So for example, like if it's easier to run a embeddings model that is perfect, that is less than 100 megabytes, can run on any platform, is very up to date and knows information from just a few months ago, whatever, I think that's going to have a way bigger impact on AI applications than anything a vector database can do, right? Because if a vector database, sure, things will get a little, like a KNN search may get a little bit faster. Sure, the recall rate will get better if you're using an ANN index or whatever. But I think like the real innovation in this space is probably going to come from like just better models, faster models that are easier to fine tune or use or restrict to your use case. I think that's where most of the innovation is probably going to come from.
Yeah. I think like the fine-tuning part, I think fine-tuning embeddings model isn't that difficult. It's more about creating the data set is very hard, and I don't think that will go away.
And I think on my side, who's never done fine-tuning and who has found all the guides like a little bit intimidating, I think that's why I think, like it should be easier to fine-tune. Whereas I think someone like you who's done it in the past or who has done fine-tuning in the past knows how easy it is, knows how whatever. So I think like it might be a little bit it just might be a skill issue on my side where I've never tried actual like fine-tuning or anything. But and also like
everything is skill issue.
And also I think it would be cool to do fine-tuning in the browser, right? Or fine-tuning in different languages. Because I imagine, maybe I'm also wrong on this, fine-tuning is usually like what? A Colab notebook that you spin up that's like only in Python that does all this stuff. But if you could theoretically, point like a fine-tuning command line interface or upload something to a web interface that's just like the data that you have with maybe some instructions, we don't have to like use a Colab notebook or use Python. You could use your own programming language or have a different interface for it. I could imagine that would make fine-tuning a little bit easier. Maybe it's not possible. Maybe I just have zero clue and don't really know like how fine-tuning works. But I think something like that could make things a lot easier for most people. Because I would imagine that like most AI application development out there, application developers, if they don't have experience in Python or like fine tuning or even just like training models themselves, I imagine it's a little bit more difficult. But I could also imagine a world where there's easier ways of fine tuning through like a web browser or something. Maybe I'm wrong. Maybe that does exist. Maybe again, skill issue, but.
Yeah, I think like the bigger issue at the moment, all the libraries focus on inference for the local stuff, because training is the type of workload is very different, because you tend to have batches and you're adjusting the parameter weights, which is especially in Llama files, since it's like one file, the parameters are hard-coded, and you would have to basically adjust them. I'm not sure how easy it would be to basically integrate all that logic, for example, in a Llama file or something like that. But that's for smarter people than me to figure out.
Smarter than me as well. The stuff they're doing in Llama file is absolutely insane. It goes way over my head, but yeah.
I tried reading into it. It's crazy. What do you think? Like, overrated, underrated? I always like to ask that. What's an underappreciated and what's an overrated technology?
Yeah, I think underappreciated, definitely like binary quantization. Looking at all the different like quantization tools out there, or all the different ways to make your embedding smaller. Binary quantization just, to me, seems so easy and works out pretty well, especially if your vectors are like large dimensions, right? So if you have a 1,000-dimensional vector, if you have a 1,000-dimensional vector and you do binary quantization on that, it is much easier to deal with. You can store in a regular database column. You don't have to worry about, a lot of times you don't have to worry about a dedicated storage, that in a dedicated way. Like, for example, a SQLite Vec virtual table, you could just store inside of a regular table and be just fine, because the actual size is just a couple hundred bytes. It's faster. It's much easier to it's faster to search. It's much easier to generate. It makes a lot more sense in my head than some of the other quantization methods. And the performance is pretty good. And I think better embeddings models can produce better quantization methods, right? If those embeddings models train on binary quantization loss, then it just works out a little bit better. It works out better for you. And I think overrated, I don't know about overrated, but I think one technique that I haven't done as much has been Matryoshka embeddings. So that is when you have an embeddings model that is specifically trained to generate embeddings that have like different breakpoints. You have a 1,000-dimensional vector, and you also have another breakpoint, a Matryoshka embeddings target for 500 dimensions or 250 dimensions, which in practice means after you get that, once you embed something and you have that 1,000-dimensional vector, you can cut off at the different places. So you can cut off and just have the first 500 elements or the first 250 elements and use those to store. And the loss that you get from that isn't that bad, right? You can just theoretically, you could just store those first 500 or first 250 elements, save on a lot of space, and just use those for different comparisons. That's great, and I love seeing it. But I think the space savings you get from that isn't that much. So, for example, like if you just store the first 250 elements in a 1,000-dimensional vector, you only save 1/4 of the space, which is great. And you can maybe do some other stuff like scalar quantization to get that down to 1/8 or something. But with binary quantization, it's 132, right? 132 of the space you use from a full floating point vector into a binary vector, there's like way more space savings. And the performance gain might be comparable if you're using a good embeddings model. Mixed Bread AI, they claim that their embeddings model that was specifically trained on binary quantization holds up at 95% quality when you do binary quantization. So 95% quality when you chop off, and we only contain 132th, how do you say that? 132nd,
I think you were right.
132nd of a space in a bit vector compared to the full floating point vector. Whereas like Matryoshka embeddings may not even be able to do that, and their quality is probably a little bit worse than 95th%. That's the reason why I think binary quantization has a lot more room to grow, especially because that can be specifically trained and easily trained in an embeddings model, as compared to Matryoshka embeddings, where you may not get as much space savings and probably have similar levels of quality after you do those, after you cut that up. So yeah, I think like binary quantization is probably going to be the future, way easier to train, way easier to use in vector databases. And Matryoshka embeddings, I imagine if I see some numbers, maybe I'll change my mind on that. But I typically reach for like binary quantization first before I even consider any Matryoshka embeddings or anything like that.
Yeah, they also have limits in terms of fine-tuning. So it's way harder to fine-tune something like Matryoshka embeddings than just regular embeddings, which you then basically quantize post hoc. And I think in fine-tuning, you like to have the choice of what to do. And you could basically do the quantization already doing the fine tuning as well, but you can also apply it after the fact. And I think that's the
Yeah.
beauty of it.
Yeah, and I think, and also with Matryoshka embeddings, I know Snowflake in their Arctic embed version 1.5 embeddings model, they talked about their initial version didn't have Matryoshka embeddings, and they added Matryoshka embeddings in that 1.5 model. But they did mention how they think that they only trained on like one Matryoshka target, right? I think it was like the full vectors, I want to say 1024, and they specifically trained for I think 256 for their Matryoshka embeddings. They didn't have multiple levels like some other models do, right? OpenAI, they trained on 4 or 5 different targets, whereas like the Snowflake 1.5 one only trained on one. And I forgot the reason why they did that, but they did have a good like comparison of, oh, when you have too many targets, the quality isn't good, something like that. They explained it more in their blog post of like why they only trained on one specific Matryoshka target. So I think there's still a little bit more to figure out on that space for Matryoshka embeddings. Whereas like binary quantization, again, like I think it just works out of the box, and it's probably easier to like, if you're fine tuning, I imagine it's easier to like include that as a loss function when you're doing that. So that's my hunch at least.
Yeah. What is something that you actually would love to see built that would make your life easier?
Yeah, I think making other machine learning models easy to run. I think one nice thing about the LLM craze in the past few years and local AI craze is that now it's a lot easier to run those types of models like text generation and embeddings models locally as to they were before. I think like those types of models in the 2018, 2019 era, you had to have to install PyTorch or install 1,000 dependencies and compile something, and it would take like a long time to really do. And it'd be like quite difficult to do, to be honest, especially if you're not a Python developer. But now, Longo.cpp, it compiles to a single binary. These embeddings models and for GGUF files, it's just a single file that you have to pass around. So now they're like much easier to run, and it doesn't require GPU. It can work on all CPUs and all that stuff. So I think that's one nice thing about AI and LLMs that happened. That's now it's just much easier to run. But I think that hasn't happened for other types of machine learning models. I think one thing like vision models that we talked about before, those are still pretty hard to run locally. I hope that they get better. I also think other models like natural language processing, some NLP models that were difficult to run in the past and are still difficult to run, or at least they don't work on all platforms like these other ones do. For example, Gliner, a new NLP model that does some transformers-based thing. I would like to see that be able to run in different platforms, whether that's like in the browser or in a C++ based model that can be embedded into other applications. Because I believe right now it requires Python, it requires a pip install, and probably PyTorch and a bunch of other larger dependencies. So I hope that like other machine learning models, like NLP models, like these vision models, will get easier to run. That's like my one wish for the next few months and years.
Yeah, probably yes. And if people want to follow along with you, hire you, see what you have built, where can they do
So
that?
I think if you want to check out SQLite Vec, if you just look up SQLite-Vec, that's -VEC, I imagine it'll be on Google. You could also go to my com/ASG017. That has a link to SQLite Vec and whatever else. I also have a website, alexgarcia.xyz. If you want to check that out, that has links to all my different socials and some of the other projects that I work on and stuff. If you want to get in contact, you could find my Twitter through there or send me an email or whatever.
So what can we take away? I think first of all, the performance boundaries of SQLite Vec are very interesting. Like he mentioned up to 500,000 vectors with like 768 to 1024 dimensions are very doable in sub 500 microseconds, which is basically the threshold for human perception. So that's like really perfect, and that's a really large index if you consider you're running on the edge or on the customer device, because nearly no customer will probably have a data set or a knowledge base that is as large. And this is for brute force search, so there isn't an ANN implementation even. So this will become really interesting down the road as it becomes more efficient. Like how much can you actually do on the edge or on smaller devices? And the optimal use cases really are like medium scale applications which are local first or where privacy is an issue, and where the sub-second search is still acceptable, but I would expect it's probably really focused on certain domains and on consumer devices
where you actually have some knowledge that you want to store on device because you don't want to share it, or because it's just faster. So you could also come up with a strategy where you just cache a set of data on the customer device and search on top of that. And in the meantime, while you show the first few results, you basically query your own main database. And then once you get the results back, you basically enrich the cached results with the results from your main database. I think this could be a really interesting pattern because you would come away with a lot more stuff where you actually don't need as much distribution across the world if you have a global user base and stuff like that, that you actually have to worry about, okay, all the networks delays that you could encounter. Also just general performance optimization tips, like use binary quantization for really large data set if you're doing it in SQLite Vec. Use metadata filtering so you can do subset searches to make it faster and more efficient. Consider basically partitioning your data as well by user or by some form of category. And also just do performance monitoring. Monitor the search latency by different vector sizes or different types of queries. The complexity, I think, comes into play with a local development workflow when you have that local database that you have to consider way more when it comes to updates to the database, because you actually have to do the migrations on each of the customer devices. And for that, to be honest, I would be over asked, like, what exactly has to happen there when you, for example, have a schema migrations in one of your tables, that you can actually push it to all the different devices. You actually can do some really interesting experiments and start way simpler with search. Like if you start the search with a SQLite database and on the customer device, or just running it embedded on an endpoint, there are different solutions for that, obviously. But if you run it embedded, it's a very cheap way of actually experimenting and also putting something in production, because the environment in which you run it, so basically the SQLite database, which is embedded on your user's device, but also and the SQLite database that is on your device when you're developing, it's the same environment, and which often isn't a given in AI and ML. So you really can take it and experiment locally and then put it into production, and it should behave like mostly the same. And I think that's a really interesting pattern that really allows you to start simple and add complexity as needed. And once your application really like hits it off, you can actually decide, okay, which database should I choose based on the query patterns you actually see in production already. So I think you have a more natural progression. You can start simple. You can do a lot of the different types of searches like keyword burst. You can do hybrids, some re-ranking, and then you monitor the query patterns. And over time, as the load gets too big for SQLite, you basically move on and pick Elasticsearch, OpenSearch, Vespa, Quadrant, depending on your use case. We will continue next week with an episode on quantization. So Alex talked a lot about it. We will be going especially into product quantization and binary quantization next week. So stay tuned for that. And otherwise, I will see you next week.